All right, in this example, we're going to take a look at another quadratic function. It tells us that Margie is standing on a bridge looking at a river below. She throws a rock over the bridge with an initial velocity of 60 feet per second. Again, I see those words initial velocity and I think physics. If the height h of a rock at the time t seconds after it was thrown can be modeled by the equation h equals negative 16, there's that negative 16 again, negative 16t squared plus 60t plus 72 to the nearest tenth of a second, will it take the rock to reach the surface of the water? I'm going to start by just drawing a picture of what's happening here. So here we go. I have my axes. She was standing where? She was standing on a bridge overlooking. So I know that, let's just say, if this is my bridge up here, it's not a very good bridge, but we're going to pretend like this is a bridge, okay? We're standing on the bridge, and we're going to throw a rock with initial velocity, which means we're going to throw it up for it to come back down. We're going to throw it up, and then it's going to come back down, and it's going to go like this. And from here to here, that's time. Time is always x. Height is where we are on the y-axis. And we know that when the height is 0, this is where we're going to find the river. This is my water here, so this is the river. I need to know how long, it says to the nearest tenth of a second. I need to know time. Will it take the rock to reach the surface of the water? So if I just follow the path, it starts up here and it goes all the way to here, the surface of the water would be right here. Now think about that. Right there is where a quadratic crosses the x-intercept. Well, that means I'm looking for a solution. And when we look for solutions, we have some options. We have factoring, we have completing the square, we have the square root method, and we have the quadratic function. While you could use 3 of the 4 in this situation, we cannot use the square root method because we have a b term. The easiest when working with velocity, the easiest to work with quadratics that are modeling real world situations where gravity is playing a part, is to use the quadratic function. So I'm going to rewrite this. I'm going to say, okay, if this is 0 equals, if I'm looking for the solution, I'm going to rewrite this. Remember that this is A, this is B, this is C. And I'm going to set that up in my quadratic equation. So y equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's set that up. X equals, well, negative b would be negative 60 plus or minus the square root of, and that's going to be 60 squared minus 4 times a, which is negative 16, times c, which is 72. Let me extend my radical sign over. All over 2 times negative 16. All right, why don't you pause and work that out and see what you come up with. Here we go. We're taking a look at using the quadratic formula. Make sure you're careful with your steps. So I have x equals negative 60 plus or minus. Well, 60 squared was 3,600 plus negative 4 times negative 16 times 72 was positive 4,608 all over negative 32. Now I simplified that down here, and underneath that square root I had the square root of 8,208. And when I put that into the calculator, I find out that it's 90.598. In the directions it told us we were going to be working with the nearest tenth, so I went ahead and rounded that to 90.6. Now remember, that's a plus or minus, which means there are 2 solutions that we need to look for. So I divided them up, and when we put them together, I end up with x equals negative 0.9, or x could equal 4.7. Now remember, x is time. Time is never negative. So this is not an option. It cannot be negative. So this is not an option. Therefore, The answer would be 4.7 seconds.